Okay, so you know how sometimes you just want to get to the bottom of things quickly?
Hmm.
Like, especially when it comes to something complicated like science. You just want to understand it fast.
Yeah, absolutely.
But then you also kind of wonder, like, well, how much can I actually trust all this information? Like, how do we even know what we know in science?
Yeah.
It's like a huge question, right?
Yeah, for sure. It is. It's like one of those fundamental questions that you kind of have to grapple with. And it's something that researchers have been looking into. And actually, there's this idea of epistemic beliefs.
Epistemic beliefs. Like,
Yeah, and it's basically like your own personal views on what scientific knowledge is all about.
hmm,
So like, where does it come from? How solid is it? Does it ever change? How do we even figure out if it's reliable? All those kinds of questions feed into your epistemic beliefs.
so it's like the lens through which we see and make sense of science almost.
Exactly. Yeah.
Yeah.
And it's really important because those beliefs can actually shape how you learn about science, how you understand it, and even how you talk about it with others.
Yeah, for sure. And I feel like that's what we're diving into today, right? Like this whole idea of epistemic beliefs.
We are, yeah, we're going to take a close look at this big study, a meta-analysis actually, that looked at this in a huge group of students, over 10,000 students in Germany from elementary school all the way through high school.
Wow, 10,000 students. That's massive.
Yeah, it's a lot of data, and they were trying to figure out, what are the different ways that these students think about scientific knowledge?
And okay, so let's back up just a bit for a sec for our listeners,
Yeah.
who are all about getting to the point effectively, why does this even matter? Like, why should we care about these epistemic beliefs?
That's a great question, and I think the answer is that understanding these beliefs, it really gives you a shortcut to understanding science in general, because it helps you see how scientific knowledge is built, how it's tested, and how it can even change over time.
Right, because it's not like science is just a set of facts that are
Sure.
set in stone.
Right. Exactly. Yeah, it's a constantly evolving process, and your epistemic beliefs kind of determine how you view that process. So it's relevant for anyone who wants to be informed about science and technology and participate in all these important discussions that are happening about science and society.
Right, because we're always bombarded with new scientific information, new discoveries, new studies. So being able to process all that effectively is super important.
Absolutely, and this study can really help us do that. So it's called Epistemic Beliefs in Science, a systematic integration of evidence from multiple studies. Kind of a mouthful.
Yeah, a little bit.
But it was published in Educational Psychology Review, and basically their mission was to identify different patterns or profiles of these epistemic beliefs in students.
Okay, so profiles like different types of beliefs almost.
Yeah, exactly. And they wanted to see, what do these profiles tell us about how people think about science? Like, how do those beliefs actually play out?
Okay, so profiles of epistemic beliefs.
I had it.
So before we dive into all that, can we just clarify what exactly are epistemic beliefs when we're talking about science?
Sure. So in the simplest terms, it's basically your individual beliefs about what scientific knowledge is and how we come to know it.
Okay.
So it's kind of like your understanding of the nature of science itself and how it works.
So not just knowing the facts, but like understanding the whole process behind them.
Exactly. Yeah, it's about how we make sense of those facts and how we decide what's reliable and what's not.
Okay, I'm with you.
Now, these beliefs, they're actually part of a bigger area called epistemic cognition, which is a fancy way of saying how we think about knowledge in general.
Epistemic cognition. Okay, so it's like the bigger picture of how we learn and understand things.
Yeah, you got it. And while epistemic cognition covers a lot of ground, epistemic beliefs are specifically focused on the nature, the source, and the development of knowledge, particularly in science.
Okay, and just to clarify, are these beliefs like set in stone, or can they change?
Well, they can definitely change over time, and they can also differ depending on what subject you're talking about. You might have different epistemic beliefs about science than you do about, say, history or literature.
Right, because like you might see historical accounts as more open to interpretation than, say, a scientific law of physics.
Exactly. Yeah. So now how did all this research into epistemic beliefs in science even get started?
Well, the study talks about two main paths that kind of led to where we are now.
Okay, two paths. Interesting.
Yeah, the first one is what they call the developmental view. And this came from researchers like Kuhn and Perry, who said that our beliefs about knowledge, they actually evolve in stages as we learn and grow up.
Stages like steps in our understanding almost.
Exactly. Yeah, so they proposed several stages. Like the first one is called realist, where you basically see knowledge as a direct reflection of reality, and you tend to rely heavily on authorities like teachers or textbooks for that knowledge.
Okay, so you just accept what you're told, pretty much.
Pretty much, yeah. Then you move on to the absolutist stage, where knowledge is seen as certain fixed and there's only one right answer.
Okay, so it's all very black and white. Right, and then things start to get a bit more complex in the multiplist stage, sometimes called multiplistic, where you start to realize that knowledge can be kind of subjective.
Okay, so like different people can have different perspectives on things.
Yeah, and it's all valid because it's just like everyone's got their own opinion. And then finally, there's the evaluativist stage where you understand that even though knowledge is constructed, some ideas are better supported than others because of evidence and reasoning.
Okay, so you start to see that there are ways to evaluate knowledge and figure out what's more reliable.
Right. And you become more critical in your thinking. So, for example, someone in the realist stage might take everything in a science textbook as absolute truth, but someone in the evaluativist stage would understand that even well-established theories can be revised with new evidence.
So it's like a journey from a very simple view of knowledge to a much more sophisticated one.
Exactly, and that was the developmental view. Now, the second path is called the dimensional view, and instead of stages, this one focuses on different aspects or dimensions of our beliefs.
Dimensions. Okay, so like different facets of how we think about knowledge.
Exactly. And the study we're looking at, they use a model with four main dimensions developed by Conley and some other researchers back in 2004.
4 dimensions. Okay. I'm intrigued. Lay them on me.
All right, so the first one is certainty. And this basically deals with how much you believe that scientific knowledge is absolute and unchanging.
Okay, so like, do you think scientific facts are always true or can they change?
Exactly. And someone who scores high on certainty, they might be really resistant to any new ideas that challenge what they already believe.
They might get kind of defensive.
Yeah, possibly. The second dimension is development. And this is about whether you see science as something that's constantly growing and changing, or if you think it's pretty much fixed and done.
Okay, so like, do you see science as a finished book or like a story that's still being written?
Exactly. And someone who's low on this dimension, they might think that the science they learned in school is all there is to know.
Yeah, I can see that happening.
All right, so we've got certainty about how stable scientific knowledge is and development about whether it's finished or ongoing. Now, what about the other two dimensions? All right, so the third one is source, and this is all about where you believe scientific knowledge comes from.
Okay, so like, who do we trust for scientific information?
Yeah, so on one end of the spectrum, you have people who completely trust external authorities like teachers, textbooks, experts, without questioning anything.
They just take it all at face value.
Right. But on the other end, you have people who emphasize critical thinking, questioning authority, and forming their own understanding through reasoning and evidence.
So it's like a spectrum from blind trust to healthy skepticism.
Precisely. And then finally, we have justification, which is about how we determine whether a scientific claim is actually valid.
Okay, so like, what makes us believe something is scientifically true?
Right, so some people might not even see the need for evidence. They just go with their gut feeling or what they've always heard.
Mm.
But others believe that scientific knowledge has to be backed up by solid data from experiments and observations.
So it's like, how much do we need proof versus just accepting things?
Exactly. Yeah, and the study points out that in an educational setting, one end of these scales is usually considered more sophisticated.
Oh, really? Which end?
So it's generally seen as more sophisticated to believe that scientific knowledge can change, that science is always evolving, that we should critically evaluate information, and that we need evidence to support scientific claims.
Okay, so it's about having a more nuanced and questioning view of science.
Exactly, yeah. It shows a deeper understanding of how science really works.
Okay, so we've got these two big ideas, the stages of development and these 4 dimensions of beliefs.
Yeah.
So how did researchers start to connect those two things?
Well, they realized that instead of just looking at each dimension separately or trying to pinpoint a specific stage, it was much more informative to look at the overall pattern of beliefs across all the dimensions.
Okay, so like a more holistic view.
Yeah, and this led to the idea of belief profiles, which are basically unique combinations of beliefs that different people hold.
So like each person has their own profile of how they think about science?
Exactly. And to identify these profiles, the study used a statistical technique called latent profile analysis, which sounds really complicated.
Yeah, a little bit.
But basically what it does is it analyzes how students answered questions about those 4 dimensions, certainty, development, source, and justification, and then it groups students together who have similar patterns of answers.
So it's like finding clusters of students who think about science in similar ways.
Exactly. And these profiles can be linear, meaning someone has generally strong or weak beliefs across all the dimensions, or they can be nonlinear or overlapping, where someone's strong in some areas but weaker in others.
Okay, so like a more mixed bag of beliefs.
Yeah, and this profile approach gives us a much more detailed understanding of how people think about science than just looking at averages.
That makes sense.
Oh.
So what were some of the key profiles that they found in this study with all these thousands of students?
So several interesting profiles emerged, and one of the most common ones was called the absolutistic profile. And these students really relied on external authorities like teachers and textbooks. They saw scientific knowledge as certain unchanging, and they believed it was justified just because those authorities said so.
Okay, so it kind of matches that absolutist stage we talked about before.
Exactly. Yeah, and this profile was found in almost all the samples they looked at.
Wow, so it seems like a pretty common way of thinking about science, at least among these students.
Yeah, it seems so. And then another prominent profile was the multiplistic one, where students believe that knowledge is mostly generated by individuals, and it's kind of like everyone's entitled to their own opinion.
Hmm. So less emphasis on objective truth and more on individual perspectives.
Right, and they were less convinced about the certainty of knowledge, and they acknowledged that science develops, but they didn't really stress the importance of evidence and justification.
Interesting. So those were kind of on the less sophisticated end of the spectrum. Did they find any profiles that showed a stronger understanding of the nature of science?
Yes, definitely. They found a profile called evidence-based, which, as the name suggests, emphasizes the importance of evidence in supporting scientific claims.
Okay, so these students really value experiments and data.
Exactly.
Yeah.
And they understand that science is based on testing and verifying ideas, and this profile appeared in a good chunk of the samples.
Okay, that's encouraging. And were there any even more sophisticated profiles?
Yeah, they found one called sophisticated, which was present in most of the samples except for one group of elementary school students.
Okay, so maybe that kind of thinking develops a bit later.
Yeah, it seems so. And these students, they didn't rely as much on external authorities. They recognized that scientific knowledge can vary and change, and they really valued evidence and experimentation.
So they had a pretty good grasp of how science works.
Yeah, they did. And interestingly, they also found a highly sophisticated profile, but only in samples from students who were in academic track schools.
Hmm. So maybe a more demanding academic environment pushes students to develop even more nuanced views of science.
Yeah, that's a possibility. And this profile showed an even deeper understanding of the complexities of science across all four dimensions.
Okay, so we've got absolutistic, multiplistic, evidence-based, sophisticated, and highly sophisticated. Were there any other profiles?
Yeah, there are a couple more. They found an intermediate profile where
Yeah.
students basically scored average on all the dimensions.
So maybe they're still figuring things out kind of in between?
Yeah, could be. And then there was a mixed profile for students whose beliefs didn't really fit neatly into any of the other categories.
So some people might have a more unique blend of beliefs about science.
Yeah, for sure. So it's not always a clear-cut progression from one profile to another.
Right. Everyone's on their own journey with understanding science.
Absolutely. And the study didn't stop at just identifying these profiles. They also wanted to see how these beliefs are related to other things about the students.
Okay, like what kind of things?
Well, they looked at things like their socioeconomic status, their science self-concept, their cognitive abilities, and their understanding of how to design experiments.
Okay, so like a whole range of factors.
Yeah, and they found some interesting connections, for example. They saw a trend where students in the absolutistic and multiplistic profiles were more likely to come from lower socioeconomic backgrounds.
Hmm. Okay, so maybe access to resources and educational opportunities plays a role in shaping those beliefs.
Yeah, it's definitely possible. And on the other hand, students in the sophisticated and highly sophisticated profiles tended to have higher socioeconomic status.
Interesting. So maybe a more privileged background can sometimes lead to more opportunities to engage with science in a deeper way.
Yeah, that's something to consider. And when they looked at science self-concept, which is basically how confident students feel about their abilities in science, they found that the absolutistic and multiplistic profiles generally had the lowest self-concept.
Okay, so maybe if you see science as just a set of facts from authorities,
Yeah.
you might not feel as confident in your own ability to understand it.
Yeah, it makes sense. And the evidence-based group often had the highest self-concept.
So maybe if you see science as a process of inquiry and you value evidence, you feel more empowered to engage with it.
Yeah, that's a good point. And the sophisticated group, their self-concept varied, but it was often above average.
Okay, so those are the findings for socioeconomic status and self-concept. What about cognitive abilities?
Well, for that one, the findings were a bit more mixed, but generally, the absolutistic and multiplistic profiles tended to have average or slightly below average cognitive abilities.
Okay.
And the sophisticated profile was sometimes average, sometimes above average. It didn't show a super clear pattern.
Okay, so it's not a simple one-to-one relationship between beliefs and cognitive abilities.
Right. And then finally, they looked at how well students understood the control of variable strategy, which is super important for designing experiments.
Right, like being able to isolate different factors and see how they affect the outcome.
Exactly. And this was a really interesting finding because the absolutistic group consistently scored below average on this.
Hmm. So maybe if you see scientific knowledge as coming from authorities, you're not as focused on testing and verifying it yourself.
Yeah, that could be a factor. And in contrast, the sophisticated and highly sophisticated groups, they consistently scored above average.
So a clear link between more sophisticated beliefs about science and a better understanding of how to do science.
Precisely. Yeah.
Yeah.
So it shows that these epistemic beliefs aren't just theoretical. They actually have real-world implications for how we think and learn.
Yeah, that's a key takeaway for sure. So what does all this mean for education? Like, how can we use these findings to help students develop more sophisticated beliefs about science?
That's the big question, and the study highlights that a large chunk of students, they hold those less sophisticated beliefs, particularly the absolutistic ones.
And we want to shift that right.
Yeah, we want to help students develop more nuanced and informed views of science because that's essential for navigating all the complex scientific issues we face in society.
Right, because if you just see science as a bunch of unchanging facts, you might not be able to critically evaluate new information or understand how science can change and evolve.
Exactly, and the study suggests that the epistemic climate in the classroom is really important.
Epistemic climate, what's that?
It's basically the overall atmosphere and teaching practices that shape students' beliefs about knowledge.
Okay, so like the environment in which learning takes place.
Yeah, and teaching methods that encourage students to be active learners, to construct their own understanding, to question things, to debate different viewpoints, those can all help to foster more sophisticated beliefs.
So it's about moving away from just rote memorization and towards a more inquiry-based approach.
Exactly. Yeah, and it's also important to explicitly talk about the nature of science itself, like how it works, how knowledge is built, how it's tested, and how it can change.
So like meta-science almost.
Yeah, kind of. And the study also mentioned this idea of epistemic diversity, which means recognizing that different belief profiles can actually bring valuable perspectives to scientific discussions.
Okay, so it's not about forcing everyone to think the same way.
Right. It's about fostering a community where different viewpoints are respected, but also where everyone has a strong understanding of the scientific process.
Yeah, that makes a lot of sense. Wow, this has been a really deep dive into how we think about science itself. Like, it's not just about the facts, but about the whole framework of understanding.
Yeah, definitely. It's kind of meta, but it's really important.
So to recap for our listeners, what are the main takeaways from all this research on epistemic beliefs?
So the big thing is that we now have a much clearer picture of the different ways that people think about scientific knowledge, these different profiles. And we see a general trend towards more sophisticated beliefs as students get older and as they go through more challenging academic tracks.
Okay, so it's a journey of development.
Yeah, and we also saw those interesting connections between belief profiles and other factors like socioeconomic status, self-concept, cognitive abilities, and understanding of scientific reasoning.
So it's all interconnected.
It is. And I think the key question for our listeners to ponder is this. Knowing that there are all these different ways of understanding science, how might your own beliefs influence how you interact with new scientific information, how you evaluate it, how you talk about it with others?
Yeah, that's a great question to reflect on. And if you're really intrigued by all this, I encourage you to delve a bit deeper into this whole field of epistemic cognition. It's a fascinating area of research.
Yeah.
And as always, we want to thank you for joining us on this deep dive. We aim to give you that shortcut to being well-informed, and hopefully this exploration of epistemic beliefs has done just that.
I hope so too. Thanks for having me.
It's been a pleasure.
All right.
Take care.
You too.
Bye.